Today we are going to study about quadratic equation. The general form of quadratic equation is ax square plus bx plus c is equal to 0, where a is the coefficient of x square, b is the coefficient of x, and c is the coefficient of x to the power 0. As you can see, it is a second degree polynomial with maximum power is equal to 2. This is a second degree polynomial. Hence, it has two roots. It implies that it has two roots. Now, roots can be rational, root can be real, or root can be imaginary, or roots can be equal to. So, how to determine the nature of roots we shall study a little bit later. Now, the most basic method to solve quadratic equation is by observation and factorization. To learn that method, let us assume an example. X square minus 5x plus 6 is equal to 0. Now let us break the 5x into 3x and 2x. Plus 6 is equal to 0. I'm taking common x from this expression, we get x into x minus 3. Taking minus 2 common from here, we get minus 2 into x minus 3 is equal to 0. Now taking x minus 3 from this, we get x minus 3 into x minus 2 is equal to 0. To this expression to be equal to 0, either x minus 3 is equal to 0 or either x minus 2 is equal to 0. If x minus 3 is equal to 0, let's assume it to be case 1. It gives us x is equal to 3. If x minus 2 is equal to 0, it gives us x is equal to 2. So we have seen that the two roots are x is equal to 3 and x is equal to 2. Now the trick lies in breaking up the coefficient of x so that its product, the product of alpha and beta is equal to c. Now let's assume this equation to be have two roots is equal to alpha and beta. Now rewriting this equation or going backward, we get x minus alpha into x minus beta is equal to 0. Now to compare these two equations, first we align the coefficient of x square. To do that, we multiply this equation by a. Now comparing the coefficient of x, we get a into minus alpha minus beta is equal to b. And from comparing the coefficient of x to the power 0, we get a alpha beta is equal to c. From here we get alpha plus beta is equal to b by a minus b by a. From here we get alpha into beta is equal to c by a. Now we know the product of roots is equal to c by a and the summation of the root is equal to minus b by a in the normal equation. Now to solve this equation and get the general solution, we first have to divide it by a, which gives us x square plus b by ax plus c by a is equal to 0. Now this term can be written as the whole square of x plus b by 2a whole square plus c by a. Now the extra term we are getting here is b square by 4a square. So we will have to subtract b square by 4a square from this equation. Now simplifying this, we get x plus b by 2a ka whole square is equal to b square minus 4ac upon 4a square, which gives us x plus b by 2a by taking the under root of both sides, plus minus b plus minus b square minus 4ac upon 2a, which gives us x plus b by x is equal to minus b by 2a plus minus b square minus 4ac upon 2a. Now this term b square minus 4ac is called discriminant. The value of discriminant is useful for us to decide the nature of roots. From here we observe that value of alpha is equal to minus b plus root b square minus 4ac upon 2a, and the value of beta is equal to minus b square minus 4ac upon 2a. So we have value of d is equal to b square minus 4ac. Now how the value of d affect the nature of roots, that is what we are going to study now. Now d can have three values. Either d can be positive, either it can be equal to 0, or either it can be less than 0. When d is positive, so we will get alpha and beta is equal to minus b plus minus root d upon 2a. That would mean that we would have two distinct roots. When d is equal to 0, that would mean that this quantity would be 0, and in this case we will have two same root, alpha is equal to beta is equal to minus b by 2a. When d is 0, that would mean the quantity root d would be imaginary. In this case, our root would be minus b plus root d by 2a and minus b minus root d by 2a. Now this is imaginary part and this is real part. That would mean these are two conjugate roots. So in this case we would get two conjugate roots. Now we are going to verify one result which we have find out earlier. We have alpha is equal to minus b plus b square minus 4ac upon 2a, and beta is equal to minus b square minus 4ac upon 2a. If we add alpha plus beta, we would get minus b upon 2a, and this factor would cancel out each other, and it would become 2 times minus b by 2a, which would mean minus b by a, and alpha beta would become minus b ka whole square minus b square minus 4ac whole square upon 4a square. This would give us b square minus b square plus 4ac upon 4a square, which would become c by a. Up till now we have studied the quadratic equation from the perspective of algebra. Now we would be going to study a quadratic equation using Cartesian coordinate methods. But before that we should solve some problems. First problem is we have to solve x square minus 11x plus 30 is equal to 0. Now using the formula which we derived earlier, x is equal to minus b plus minus b square minus 4ac upon 2a. Here b is 11 C is 30, A is 1. So X becomes minus B, B is minus 11, plus minus 121 minus 4AC minus 120 divided by 2, which gives us 11 plus minus 1 upon 2, which means X is equal to minus 11 plus 1 by 2, that would be 6. 11 minus 1 by 2, that would be 5. So our roots are 6 and 5. And one thing which I forgot to mention earlier was that this formula is called Sridharacharya formula. It was named in the honor of the Indian mathematician who derived this formula. Second problem we are going to solve. We are given alpha plus beta is equal to 4 and alpha beta is equal to 4. We have to find values of alpha and beta. To solve this equation, we have to convert these two equations into quadratic equations. To do that, we know the summation of roots alpha plus beta is equal to minus b by a, which is given to be 4. Product of root is c by a, which is given to be 4. So b is equal to minus 4a, c is equal to 4a. Putting these values in standard equation of quadratic, we get ax square minus 4ax plus 4a is equal to 0. Divide this equation by a, we get x square minus 4x plus 4 is equal to 0, which gives us x minus 2 whole square is equal to 0, which gives us x is equal to 2. And x, since it has single root, it means alpha is equal to beta is equal to 2. Now we are going to study about geometric approach to understand quadratic equations. To do that, we would first have to consider a function y is equal to fx is equal to ax square plus bx plus c. As we know that this is a parabola, this is an equation of parabola whose axis is parallel to y axis. To draw this, we would first have to draw coordinate axes. This is x axis, this is y axis, and this is our parabola y is equal to fx. Now it can have two orientation, either it can be like this or it can be upside down like this. So the deciding factor would be our value of a. If our a is positive, then y is equal to ax square plus bx plus c would tend to infinity as x tends to infinity. That means it would have this shape. If our a is negative, that means the term ax square will dominate bx plus c, and as x tending to minus infinity or plus infinity, the value of ax square plus bx plus c would go to minus infinity. So this is a less than 0, this is a positive. As we have seen before, the value of discriminant d affect the nature of roots. In graphical format, how it comes into play, we shall inquire it now. So there are three cases: d positive, d negative, and d is equal to 0. D positive means it will have two real roots. That means the nature of the parabola would be like this. This would be alpha and this would be beta. If d is equal to less than 0, that would mean either parabola is like this or it is like this. And if t is equal to 0, that would mean it would be touching the x-axis, giving only one root. This is d is equal to 0, this is d greater than 0, this is d less than 0. The second format here would be this. This means no real values, this means only one. This means alpha is equal to beta. Now we shall do some example. First example is x square minus 5x plus 6 is equal to fx. As you can see, it has two values as roots, x is equal to 2 and x is equal to 3. So to draw this parabola, it would cut x-axis at 2 points, x is equal to 2 and x is equal to 3, which are its solutions. And its shape would be like this because the value of a, which happens to be 1, is positive. Now to find out this value, what is the minimum value it attains, we have to consider the fact that the axis of parabola is parallel to y-axis and the curve is symmetric about its axis. This is axis of parabola. This is also axis of symmetry for the parabola. So now from this point we can see this point is midway between x is equal to 2 and x is equal to 3. So the curve attains its minimum value at x is equal to 3 plus 2 by 2 is equal to x is equal to 5 by 2. Now to get the minimum value of this equation, we would put f 5 by 2 would give us minimum value of this expression. Now the second example is x square minus 4x plus 4 is equal to 0. As you can see, it has root minus 2. It has root its only root is x is equal to 2. To draw this parabola, we know that it would touch x-axis at one point and that would be x is equal to 2. So this would be our solution. Now the third example. Fx is equal to x square minus 4x plus 8, which is its roots are minus b plus minus b square minus 4ac upon 2a. So its alpha and beta would be minus b between 4 plus minus b square minus 4ac upon 2a. That means that its roots are imaginary, and since the coefficient of x square is equal to 1, it means the parabola would be of this shape and it would never touch x-axis and it has no real roots. So that was all about quadratic equations. My name is Ravi Kumar. I have done my BTech from Mechanical Engineering from IIT Kanpur. This was the presentation I was asked to give. Thank you.